In this lesson, we are going to learn about outliers and trimmed mean. An athlete's sprint times are recorded for a 1-month period. So what is this athlete's mean time for this month? So for the mean, we want to add all of the times together and then divide by how many there are. So when we add these together, we end up with 75.6. So when we find the mean, we're going to use that 75.6 and we're going to divide by 20 because there are 20 times for this month. So when we do that, we get a mean or an average of 3.78 seconds. So is this mean higher or lower than you expected from the numbers? So in my opinion, this is a little bit higher than what I expected because as I look at the data, I found that most of the times were about 3.2, 3.3, 3.4 seconds. So 3.78 or almost 3.8 seconds seems a little bit high because most of the values that I see are in the lower 3.3s. For number 3, are there any times that seem unexpected or irregular? So when I look at the data, a couple of points definitely stand out. So 9.2 seconds and 6.8 seconds. Those two definitely stand out because most of the other values or times are in the 3-second range. So 9.2 and 6.8 seconds are too high compared to the rest of the data. In the data table, sprints 5 and 9 are outliers. That's what we identified in the last question. So 5 is 9.2 seconds, and sprint number 9 is 6.8 seconds. So these are outliers because their times are abnormal compared to the rest of the data. So 5 and 9 are outliers. They're values that lie outside the normal range of the athlete's sprint times. So how does including these two values in the calculation affect the mean? So when we found our mean, it ended up being 3.78 seconds. So when we added in these 9.2 and 6.8 seconds, it made the mean higher. So we're going to try the calculation again, but this time we're not going to include the outlier values of 9.2 and 6.8. But if we remove the two highest outliers, then we also have to remove the two lowest data values just to keep the data even. So we can't take away the highest two and leave the lowest two. We have to balance it out. And if we take away the highest two, we therefore have to take away the lowest two. So we're going to redo this, but this time we're not going to include data points 5 and 9. Those are the highest ones. And our lowest values are 2.8 and 2.7. So we're going to calculate this again without those 4 values. So when we add up the rest of the times, we will end up with 54.1 seconds. So we'll take this 54.1, and this time, instead of dividing it by 20, we're going to divide it by 16 because we've eliminated 4 of the data points. So when we do that, we end up with 3.38 seconds, which seems a little bit more consistent, considering most of the data, or most of the times, are between 3.2 and 3.6 or 3.7. So this seems more like a more realistic mean when we don't use those outlier values. The mean found by omitting an equal number of values at the upper and lower ends of a data set is known as the trimmed mean. So in the last example, the second mean that we found is actually the trimmed mean because we took out the highest times and the lowest times for the sprint data. So for a data set with outliers, the trimmed mean is a better measure of central tendency than the complete arithmetic mean. So the trimmed mean is more accurate than the mean that we would find with all of the values included. Quill work is the use of dyed porcupine quills to ornament practical and spiritual objects. This was traditionally used by First Nations people, including the Cree and the Dene. Today, glass beads are more commonly used than dyed porcupine quills. So Louise has been making these purses, and she keeps track of how long she spends on each item that she produces. So this helps her calculate the object's price. So her hours spent on the last 10 purses she made are 6 hours, 8 hours, 37, 3, 9, 6, 8.5, 5, 7.5, and 9. So what is the mean number of hours Louise spent on each purse? So just the regular mean, we include all of the data points. So when we add all 10 of these values together, we get 99. To calculate the mean, we need to now divide by how many there are. So there are 10 data points here because these are the last 10 purses. So 99 divided by 10 is 9.9 hours. So on average, that's how long she spent on each purse. What is the trimmed mean of hours spent on each purse? So the trimmed mean means that we're going to eliminate the outliers. And the outliers in this example are 37. I guess the one outlier is 37. When we find the trimmed mean, we need to eliminate the largest outlier as well as the smallest outlier. So 37 is way too big, and the smallest one is 3. So we're going to eliminate the 37 and the 3 from our calculations this time to find our new trimmed mean. So now when we take out the 37 and the 3, we end up with 59 when we add the rest of those data points together. And this time, instead of dividing by 10, we've taken out 2 of our data points, so we're only going to divide by 8 this time. And when we do that, we end up with 7.375, so 7.4 hours. So this seems to fit a little bit better because most of our data points are between 6 and 9 hours. So 7.4 seems a little bit more reasonable than the 9.9 or the almost 10 hours in the actual mean. Which seems like the more average number of hours spent on each purse, and why? So the second one of 7.4. And this is because most data points are between 6 and 9 hours. Last question says, what might explain the outliers in this case? So why was there a value of 37 and why was there a value of 3? So what explains that? So when Louise was making these purses, on average, most of them took about 7.5 hours. For one that took 37 hours, maybe this purse was very large, or maybe it had very intricate details on it. So maybe there was some very intricate beading work that she needed to do. So that would have taken her a lot longer if it was a larger purse and very intricate beading. For a purse that only took 3 hours, we can say that this was maybe a very small purse. And maybe there was a very simple beading pattern that needed to be put on, or just very little beading work. So that would explain a possible reason for the two outliers.